Bismillahirrahmanirrahim. This video is of the series application of Laplace transform, and primarily here we'll be solving practice problem 16.1. So the practice problem 16.1 states that determine V naught T in the circuit. Now if you look at this circuit, the V naught T is across this 4 ohm resistor, or the output voltage here, V naught T, and we have to assume the initial condition to be 0. So first of all, we transform the circuit into S domain, and I hope you recall that for ut we write 1 over S. Inductor is written as SL, and so if there is a 1 Henry inductor, it will become S into 1, so S. Capacitor is written as 1 over SC, so 1 over 4 farad will become 1 over S divided by 1 over 4, so that will become 4 over S. So we plug in these values here in the figure, which will make it in S domain. So first of all, the current source is 10 ut, so it will become 10 into 1 over S, or 10 over S. Capacitor on the left will become 4 over S. Inductor of 1 Henry will become simply S, and there will be no change in the resistor, but the output voltage will now be written as V capital naught S, so to represent it that we are in the Laplace domain. Okay, now from here, to find this voltage, all we need is to find the current I2, and this we can do by simple current division rule. This is the total current dividing into two parts. So total current 10 over S dividing by the total impedance. The total impedance is 4 over S and 4 plus S. So divided by the total impedance and multiplied by opposite arm. So we want current in this arm, so we'll multiply by the impedance of the opposite arm. So 4 over S. And solving, I hope you can follow these steps. We have taken LCM here and then simplifying. So this is the simplified form of I2. Now we have to we know that the voltage, output voltage, will be I2 into the resistance 4. So V naught S will be I2 into 4, so 160 divided by S into S plus 2 whole square. But this is in Laplace domain. To go into the time domain, we have to use partial fraction. Okay, so partial fraction, again, if you have forgotten this formula, you have to consult your book, or you can watch my videos about inverse Laplace transform. Okay, so we write A over S for this, then we write B over S plus 2 whole square for this, and then we write C for only S plus 2. So there are 3 terms A, B, C that we have to find, and by residue method we'll find this. So A, this value A will be the denominator multiplied by V naught. So S multiplied by V naught, and putting S equal to 0, that is the condition. So S multiplied by V naught, this value, simplifying, it will become 160 divided by S plus 2 square, S equals 0. So putting S is equal to 0, it will be, answer will be 40. So that is first part, A part. Similarly, B, we multiply by the denominator, so denominator is S plus 2 whole square, BV. Simplifying, putting the value of S equal to minus 2, this value, this is equal to 0, therefore S will be equal to minus 2. So minus S equal minus 2 is the condition, and putting the values, the answer for B is minus 80. And then for C, now for C, since we already have used s plus 2 square, so the technique is that we differentiate this part. Differentiating this whole equation, the s plus 2 square vs, and differentiating and putting the value of s plus 2 equals 0, that is s equals minus 2, putting the value here. I hope you can follow this, you can simplify this, and the answer here is minus 40. So we have got A, B and C. So will now be putting in the value of A, B and C. Now we can use the inverse Laplace transform to go into the time domain. Now keep in mind the formula between Laplace transform formula, so we'll be using this formula here. So in the first case, 40 divided by s, or 1 over s we know is ut, so we'll write it 40 ut. This one is s plus 2 whole square, so we'll be using this formula. So it is t e raised to the power minus 2t or minus at. From here our a is 2, and similarly in this case it will be simple 40 e raised to the power minus 2t, and we write ut with all of them because here we are dealing with unilateral Laplace transform. So this is the answer, and the answer given in the book is same. They have just taken common 40. So this is the final answer. So I hope you have learned or understood how you can solve this type of a problem. Thank you.